Hey everyone, in the previous video we solved system of equations of two variables by elimination. This time I just want to do an example where the system of equations contain three variables. Here's our example. What is the value of x, y, and z for the equations 3x plus 2y minus z equals 8, x minus 3y plus 2z equals 7, and x minus 2y plus z equals 4. First, let's just declare the three equations as the equation 1, 2, and 3. First, we want to eliminate one of the variables, x, y, or z, through a combination of two equations, and this can be done through addition or subtraction. From equation 2 and 3, we see that coefficients of x is equal to 1. So let's try to get rid of x first by doing equation 2 minus equation 3. And if we subtract the two equations together, we should get the result of minus y plus z equals 3. And let's call equation number 4. Notice that for our equation 4 here, it is the first variable that does not involve the variable x. However, we cannot solve this equation yet because there are two unknown variables. And since there are two unknown variables, we need two unique equations in order to solve this equation. So what we want now is to have another equation similar to equation number 4, where it contains the variable y and z, but does not involve the variable x. So we get this equation through a different combination of equation that is different from equation number 2 minus equation number 3. And this time we chose equation 1 minus 3 times equation 3. And we do this because the coefficient of x for equation 1 is 3, coefficient of x for equation number 3 is 1. And through subtraction, we get that ay minus 4z is equal to negative 4. And let's call this equation number 5. Moving on to a new page, let's just write down all the equations that we have so far. So the first three equations are the equations that are given to us, and equation 4 and equation 5 are gathered from the original equations. Now that we have two different equations that contain the variables y and z, we just repeat the elimination process. So if we choose to get rid of the variable y, we see that in equation 4 the coefficient of y is 1, and equation 5 the coefficient of y is 8. So we do 5 plus 8 times equation number 4, and the result will give us z equals 5, and we'll call it equation number 6. Now that we have the value of z, we can either plug it into equation 4 or 5 to get the value of y. In this case, we plugged it into equation number 4, and we can see that the result of y is 2. And now that we have the value of y and the value of z, we can plug these two values into either of equation 1, 2, or 3 and get the value of x. In this case, we plugged into equation number 2, and it turns out that the value of x is equal to 3. To check our work, we just simply plug the values of x, y, and z into the original equations. And if the left-hand side and the right-hand side for all equations are equal, then that means the answer is correct. Here is a practice problem to help your understanding. And in the next video, I will show you how to solve system of equations using matrices. And you will find that this is a much better method than using elimination and substitution.